How do you even start a video? Knowing that you're probably covering the second most important year of an engine's development as a whole. Were it not for the leaps I made in the year that followed, this would be the crown jewel of the entire project. So much happened during this time that even going back through old screenshots and notes, I kept feeling like I was skipping things. Like there was no way all of this had fit into a single year, but it certainly had. There's something worth keeping in mind though. The difference from 1 to 10 feels enormous, gigantic even, but the difference from 100 to 110 barely registers, even if the actual distance is exactly the same. All of that is to say that at this stage of the project, everything was a huge, dramatic change. And while I want you to feel that with past me, I also want you to understand it only gets bigger from here, even if it may appear smaller. To recap where we left off, I had just implemented and understood BSP trees, the skeleton of a lighting system, and a map editor that was functional in the loosest possible sense of the word. Certainly a foundation, yes, but not what anyone would look at and immediately recognize as an engine. Yet. What I didn't realize going into this year was that I was spending a lot of it planting seeds. Not literally, though I do love gardening. As with most words leaving my mouth, I mean it in a more deeply metaphorical sense. Some of these seeds grew into the most prideful parts of the project, while others became some of the ugliest, most disgusting problems. Running underneath almost everything this year was Rockwall, my map editor, metastasizing alongside the engine itself. Every new feature I added needed editor support, so I kept bolting things on without much of a game plan. This eventually led to an enormous amount of what those of us in the biz call technical debt. Succinctly, Rockwall was becoming a rat's nest. A terrible, sprawling, unmaintainable catastrophe of a program that was the result of taking a learning exercise and trusting it with more responsibility than it was ever built to carry. Some part of me was certainly aware of this at the time, but I was too preoccupied to fix it until later. An example being my unfinished business with lighting. There were two things still missing from my whole lighting setup: real-time lights and models that responded to both real-time and static lighting. I had a decent handle on real-time lighting from basic OpenGL tutorials long ago, I thought, so I started there. Firstly though, to understand the choice I had to make, you need a quick primer on the two fundamental approaches to rendering a lit scene. The first is forward rendering. It was the de facto way of doing rendering for a long time. Basically, your GPU calculates lighting for every pixel of a surface, whether that surface is behind others or not, and the more geometry you have overlapping, overdraw, the more redundant work gets done and immediately thrown away. More lights make it worse, since even more work is thrown away for each pixel. There are pros, of course, with a large one being that it's not all too painful to implement. The second is deferred lighting, which at this point in the project I'd only really ever heard mentioned in passing. The idea is that instead of calculating lighting as you go, you first render everything into a collection of special textures, position, surface normals, and material data. Then, after rendering, you take those textures and work out the lighting from what's actually written to the screen and everything in the scene. The great benefit of this is that dynamic lights stop being nearly as expensive the way they are with forward rendering. It was new to me, and it was interesting. So in the spirit of learning, I decided to try it. After a fair amount of wrestling with it, I got it working. It looked fine. I say that in the past tense because, eventually, I would tear it out entirely and go back to forward rendering. The reason is pretty simple: transparency and MSAA, both of which are, for reasons I won't get into here, somewhere between difficult and nightmarish to implement correctly in a deferred pipeline, at least for me. And I generally don't like deferred to begin with, but all of that wouldn't happen until later. After that, getting models lit correctly was the next piece. Indeed, I had way over-exaggerated the difficulty in my own mind. The system worked something like this. Special brushes with a tool light node volume texture would become light node volumes. Later on, I would make the system automatic and not require any special brushes. Inside of the bounding box of these volumes, I'd spread out an even distribution of light nodes. During compile time, each of these light nodes is walked, and its lighting contribution is determined the same as points on the light map itself. At runtime, the closest node volume to the model is found, and its closest child is used for the lighting data. Of all of the systems introduced during this time, this is one of the only ones to have hardly ever been touched, and the changes I did make will be covered later. With that, though, even as clunky as it all looked, it was starting to feel a bit more believable, a bit more like a real place with nice lighting and... I should probably tell you what place I was actually building. From the very beginning of Chisel's existence, development wasn't being done in some kind of blank generic test world. It was being done inside a specific game, a particular project that, in all honesty, is the only reason Chisel exists at all. Several years before any of this, I had been making some small, basic projects that are long since eradicated from the internet. It was through those, however, that I made a connection with someone, a French friend who did some voice acting for me in some of my little projects. We kept in touch, and eventually it turned out he had an idea for a game, a small team of people, and they just needed a programmer. Conveniently, at that very same time, I was looking to expand my skill set and work on something I could actually be proud of. So I stepped outside of my comfort zone and asked to be brought on. Little did I know. Well, for a long time, we mostly just talked about it. The team changed shape more than once, and it had shed a lot of crew members over time. Through those early years, I went from being the coder, to the coder and texture artist, to the coder, texture artist, and modeler, to... let me check my notes. The coder, texture artist, modeler, voice actor, composer, sound designer, second to Mr. Frenchie, animator, and designer. Over time, we had settled into a core team of 3, me, him, and his partner. At some point, we actually sat down and spent a couple of years building a small, rough, ugly proof-of-concept demo that is now thoroughly unlisted from everywhere, partially because of the Unity nonsense I mentioned in the previous part. It was really, really bad, but it proved that this team could actually make something together, and that was enough for me. I don't want to share too much about what the game actually is, but I can tell you that it is single-handedly responsible for a considerable portion of who I am as a person right now. The music that I make that features in my videos, my modeling ability, my understanding of animation, my eye for textures, and none of that would exist at anywhere near the level that it does now without this project needing it from me from over the years. So maybe the French did something right after all. All of that is to say, when Unity pulled the rug and I decided to build my own engine, it wasn't, well, I wanted to make an engine someday anyway. Rather, it was, I need an engine for this game, and I'm going to build it. The plan to make Chisel into a more general-purpose engine that I could use for all of my games, though, came pretty early on. Still, at its heart, Chisel was built because of this project, and that alone is probably largely responsible for why I pushed through it. I just couldn't let it rot. Not this time. So development continued, and my engine kept growing. Skyboxes went in, and learning how to do that was its own interesting jaunt. More texture work in general, and a lot of learning on my part about what actually makes texture work look good to me. These may seem like relatively small things to talk about, and in isolation they sort of are, but it helped to start making it feel more like an engine than some tech demo, like all of the 3D quote-unquote engines you see all over technical communities. But the next big thing was indirect lighting. Up until this point, every lit surface in the engine was only receiving direct light, but fortunately, light doesn't work that way at all. Light bounces everywhere, off the walls and floors and ceilings, and fills in shadows, creates subtle color bleed, wraps into corners, and obviously bounces into your eyes. The absence of that in a renderer makes everything look, well, wrong. You might not be able to name what if you had no context, but it's just not right. The system I built to address this was patch-based, largely based on my understanding of Quake 2's approach that I learned from, you guessed it, Matt's ramblings again. Mine worked, and actually still works, albeit just a lot smarter, by taking the light map UVs of every face on the map and attempting to subdivide those into smaller regions of a target size. If it's too long vertically, then split it in half vertically, and same thing horizontally. These are then added to a list of patches, where it also keeps track of the space in UV space that this patch occupies. From this list of patches, a transfer list for each is computed that determines how much light gets transferred onto other patches. Put a pin in that, because this is where a lot of touching up has happened, though I'll go over that when it's more relevant. After lighting is computed, patches each average the amount of light inside them, and then, using the transfer functions, they shoot it back out to other patches multiple times to simulate bounces. Then the patches add their color back to the light map. Later, I'd use interpolation between them, and even later I'd add smarter interpolation. But for the moment it worked. The moment I compiled the map and saw light actually bounce from a wall or a floor and flood a room the way it does in the real world, I had this incredible feeling of, oh my god, that's it, it's done, I made it. I was naive, of course. It was far from complete. But in that moment, seeing something I had only ever seen in engines made by studios with entire teams of engineers sitting there in their own little project, it was something magical. It's these moments in a project that fuel you to keep working, keep trying, and keep pushing. As I said before, pretty soon after, I added some basic interpolation to smooth things out, and it helped, but not much. I didn't have the knowledge yet to fix it properly, but I also knew that given everything I'd already figured out from scratch so far, I'd get there eventually. I'd probably come back in a year and fix it up, so I moved on from that for now. It was around this time that development started to ebb and flow in a way it hadn't quite before. I've always worked in bursts, weeks of nothing followed by a month where I somehow get 4 months of work done, but this particular slowdown was the game itself pulling me away from the engine. Because the game needed my attention too, like a sad, lonely little baby. It needed characters, and it needed textures, it needed assets that couldn't be waved away, and, indeed, I loved making them. I always have. Something I haven't talked much about is how much I love things that are now considered old or antiquated. 60s to 90s era music, physical media, and especially old game development techniques if it wasn't obvious enough already. One of these techniques, from back around the Doom era, was using actual clay models as source material. You'd sculpt a character, photograph it from every angle, and those photographs would become the basis of the sprite work. Games like My Love and Joy Blood did this, and the results were gorgeous in a way that purely digital art from that period just wasn't, in my opinion. So, after barely any deliberation, I decided to try sculpting characters out of clay, with the original plan being to scan them and use those scans as reference in the actual game. I never quite got to that part, and those models now live on a paper plate on a shelf in my room where they've been ever since. But I don't consider that a failure. There's something grounding about spending hours working with your hands on something tangible in the middle of a project that lives entirely in the abstract. Photography has always been something I've loved too. You'll notice it shows up in my videos pretty regularly, and this period had a lot of that as well. Studying surfaces, lighting, and how materials actually behave. It was kind of research, but without being tedious research. It's strange in retrospect how much of what made the engine better during this period wasn't engine work at all. When I did come back to Chisel properly, a few significant things happened in fairly quick succession. 3D skyboxes went in, the trick that the source engine used where you could optionally project a tiny space to be a lot larger and appear outside the map. If you've ever no-clipped outside a map and seen those tiny mini spaces, that's the same thing. Then there was the map generator. This one is less glamorous, but worth mentioning because nobody tells you at some point you're gonna have to write your own map generator, because you're usually not supposed to. A map, for the uninitiated, is essentially a pre-shrunk version of a texture so that the engine can use the appropriately sized one depending on how far away a surface is. This prevents textures from shimmering or aliasing when they're distant. Every engine has this. Most engines just do it, and even something as simple as using OpenGL directly has a function for doing this. Monogame, for whatever reason, does not expose this to you. I got to build mine, because there was no way for me to add texture quality settings without regenerating the maps. It was important to me though, because far too many people think that turning up the map bias is equivalent to a texture quality setting, where the real purpose is to reduce the memory usage of your textures. Generally, it only makes a big difference on older hardware. Speaking of older hardware, it was around this time that I ran Chisel on a 2008-ish era computer for the first time. I have a somewhat unhealthy collection of old machines. Old servers from the school district with connections I'd made through their IT team, my own old hardware, my parents' old hardware. I find it incredibly useful. A 2000s mid-range machine is about as hostile of a testing environment as I could think of for a C# monogame engine, given how confidently everyone had told me that the whole stack was a performance disaster waiting to happen. To my surprise, however, it easily ran over 60 frames per second. I didn't have a frame profiler at this stage, so I couldn't give you an exact number, but I could tell it wasn't even close. It absolutely should have been a slideshow, but that little shitbox wasn't even breaking a sweat. This also became a habit. I would return to that machine, and others like it, again and again throughout the project. Sort of a North Star, in a sense. I wanted to make something that ran well for people who didn't have the luxury of modern hardware. Luckily, the number of frames on these machines has only gotten higher with time. Meanwhile, after a humbling dosage of struggle, I had gotten skeletal animations working, which was really exciting. It meant I could do more than stupid static props, but it came with a realization that had been building for a while and had finally arrived while I was working on it. Everything to do with models and Chisel was running through FBX. FBX is a model format owned by Autodesk that has more or less become the de facto standard for getting 3D assets from one piece of software software to another, though it is a rather uninteresting and bland format. It's great for transporting mesh and animation data, but nothing else, obviously. By the end of this year, I was done tolerating it. The friction had been growing slowly enough that I could ignore it for a long time, but knowing just how limited I would be if that's all I had was a very depressing thought. I had big plans for things like ragdolls and attachments and all kinds of things that a basic mesh format wouldn't be able to provide me on its own. The solution to that would become one of the bigger undertakings of the next year, but I want to plant that seed to build suspense for the next installment. The collision system also chose this year to begin revealing how terrible it was, which was entirely expected and had been coming for a long time. The simple axis-aligned bounding box collision I'd built in the early days had been holding everything together through my own pure stubbornness. Strange bugs started appearing. Edge cases the system hadn't been designed to handle because it hadn't been designed. I fixed those specific bugs, which was its own undertaking for plane-related math for non-axially aligned brushes. I also added support for rotated boxes, and still stopped well short of what you'd actually call a physics engine. That particular can got kicked a little further down the road, but this system's days were clearly numbered. At some point during all of this, I finally made a second test in Chisel. Third person this time, just to see what it felt like building something completely different with the same tools. It felt good, and that itself also felt amazing. The whole point of Chisel was to be something I could use for anything, and actually proving that to myself was a big milestone, even if my demo was lackluster. Yet again, after feeling like there was nothing more to do and I had simply peaked, I watched an incredible video by, you guessed it, Pinsplash! What, you thought I was gonna say Matt's Ramblings? Who's that? Pinsplash's video went over the AI navigation system in Source, and it made me realize that I was missing a similar feature. It didn't take all too long to implement. I first added a new entity to the engine, the ground node entity, and then added a new structure to the maps, a node graph. Pinsplash's video covers these things in a lot more detail, but essentially during compilation, all of the nodes are linked together based on whether there is a walkable path between them, and then, during runtime, an entity can query the graph and use an implementation of A-star pathfinding to navigate between nodes. It was remarkably easy stuff. Or perhaps, no. Was I becoming more skilled? It felt like something I would have struggled with in the past, but it was so simple. Perhaps I'd really grown since the beginning of the project. Terrains rounded out the year, which was another system I'd been putting off, and another one that required solving a set of problems I hadn't encountered before. It really wasn't anything far too noteworthy. 2023 had been a hard year. I won't get into it here, but there were stretches of those last few months where the engine was one of the only things that had clear forward momentum, and I was grateful for that in a way I couldn't have articulated at the time. I had a pretty big shift in my life that year, and while it was a good pivot for me, it led to me feeling very lonely. I got myself in a lot of messes and sticky situations, and all in all it felt like 2024 was not looking up for me. I was wrong, and even life outside of the engine was phenomenally better after 2023, but it was still good to have the engine as a constant to push me through that rut. As far as the engine and my life went, it really did end up being that 2024 was actually all coming up Elgin and Chisel. The engine ran beautifully on hardware I had no business running on. I had all the features I'd ever wanted, even in a barely usable and very rudimentary state that feels almost elementary looking back. Looking at it then versus the noise-smeared geometry of a year earlier, the difference was almost impossible to reconcile. Something that had once been a fancy map viewer was becoming unmistakably an engine, and I still had no idea what was coming next. Thank you to my channel members and patrons, who make videos like this one possible, and especially the Godly Raisins, Spano Spy, Max Not Cool, which he definitely is, Dirty Weasel, and Telvy Phil. You can support me on either platform and get exclusive perks, such as early access for all future content. Thank you everyone, and even those of you who just watch my content.